Good morning to all. On behalf of Organizing Committee, I, Ambika, welcome you all at the session of invited talk organized by Department of Biotechnology, VNSGU, South Gujarat University, Surat. On this occasion, we have with us our guest, Dr. Abdul Mahbood Khan, Scientist G, In Charge Director, ICMR-National, JALMA Institute, Agra. I welcome you, sir, and request Dr. Khan, Dr. Gaurav Shah and Dr. Preeti ma'am to grace the dais. Thank you all. Taking the program ahead, I request all the audience and dignitaries on the dais and off the dais to stand up at their respective places for University Song. Thank you all. Please be seated. Before starting to enlighten our minds with knowledge that we seek through this program, let us all pray for strength to acquire and transfer the knowledge from Ma Saraswati. I request the distinguished dignitaries on the dais to lighten the lamp. या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभुदिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा निःशेषजाड्यापहा. Thank you, madam. Thank you, sir. Now I request Dr. Gaurav Shah, Coordinator, Department of Biotechnology, to welcome our today's guest with a token of our warm wishes. Thank you, sir. I now request Dr. Shah to share his thoughts and welcome one and all.
Good morning, all of you. Respected Dr. Abdul Mahbood Khan sir, Dr. Preeti Sharma from our department, teachers, colleagues, invited guests, and my dear students. On behalf of Department of Biotechnology, VNSGU, South Gujarat University, I welcome you all. In welcoming itself, I would like to first of all thank Dr. Preeti Sharma for making this possible. Such type of academic event, lectures are very much essential apart from co-curricular and extracurricular activities. Sir is going to talk related to the most important aspect, that is applications of biotechnology in biomedical research, and you know the importance of biomedical. Apart from that, another important thing is that he is going to discuss in session 2 related to biomedical research, research proposal writing and funding opportunities. Government of India with various agencies, they are investing, they fund, and there are many opportunities related to that. And I think sir will agree with me, because what sir we promote entrepreneurship. What we call that it is very much essential, it is a high time that we should produce not job seekers but job givers. And we are following the path in the way that students are motivated to come up with their ideas, innovations, to start their own startup. Or else there is another opportunity also, that if you don't want to start your startup, and that is not possible for everyone, what you can do is that you can do a good research, you can go for IPR protection, patent, and sell it to some other startup. So these are the two ways. This is how our academic fraternity can contribute. We can always motivate you You have ideas, you have potential. The only thing is that directions are essential. And for that, it is not only the duty of department, university also helps in arranging such type of academic events. And I once again welcome as well as thank Dr. Khan, and I hope all of you will be benefited. Sir, this audience is having not only students of post-graduation, but we have academics, teachers, research scholars, as well as many from business also. So I think they are waiting for your talk related to that what are the potential opportunities and how they can get fund, because in biomedical research or biotechnology research, funding is a big issue. We have ideas, we have many things in mind, but then how to execute it, how to implement it, funding is required, and Government of India has so many schemes to fund you. So only thing is that we need to connect, and this is a right time to establish that link. So Department of Biotechnology, Veer Narmad South Gujarat University, role of this department is to establish a link between you and those resource person who has a potential, who has a knowledge. He is working as a scientist, he has so long experience, he can guide you throughout that. So what I expect from this session, apart from whatever he is going to present, there should be some brainstorming exercise. There should be some queries, some questions, if at all you have, then that will be more effective way to learn and understand what actually he wants to convey. So most important, before I conclude, most important thing I would like to let you know that though we haven't kept any registration fees, it is free, but actually you are investing your time, and that is very much important. We all are investing our time, and you have to pay something for it, and that payment is your attention. So if you will pay, you will get it, and I hope for very bright and successful academic and research career to all of you. Thank you once again.
Thank you, sir. Thank you for extending the warm wishes. Now I request Dr. Preeti Sharma to introduce our today's guest.
So a very good morning to all of you, and it is my great honor and pleasure to introduce Dr. A.M. Khan. And Dr. Khan is currently Scientist G and Director in charge of Indian Council of Medical Research, National JALMA. JALMA stands for Japan Leprosy Mission for Asia, and it established in 1963. Institute for Leprosy and Other Mycobacterial Diseases in Agra. And Dr. Khan completed his master's degree from Aligarh Muslim University, Aligarh, and PhD from Central Drug Research Institute, Lucknow. He joined ICMR in 1992 as Scientist B at Dibrugarh, Assam, and worked extensively in all states of Northeast India. Before taking the responsibility of JALMA, he was working at the Division of Epidemiology and Communicable Diseases, ICMR headquarters at New Delhi as a head. And during the COVID pandemic, he actively participated in research and coordinating committees of COVID-19 diagnostic facility and development of infrastructure to fight this disease. And during the pursuit of the career, Dr. Khan has worked extensively in the areas of epidemiology, drug development, immuno and molecular diagnostics, immunoprophylaxis, and molecular biology, dealing with lymphatic filariasis, malaria, visceral leishmaniasis, and vector-borne viral diseases. He has more than 35 years of research experience in the area of biomedical research. Dr. Khan has published more than 75 original research papers and presented his research work in national and international conferences held in Italy, Spain, France, and South Korea. So it is such an honor for us to have you today, sir, and thank you so much for coming. Thanks once again.
Thank you, ma'am, for doing this honor. Now, today's program, as you must have now briefed enough, that will have 2 sessions of 45 minutes each, including a 5-minute session for question and answer, followed by each talk. And we will have a 15 minutes break between the 2 sessions. Now, I request Dr. Shah and Sharma to please join the audience so that we can start this session. In his first session, Dr. Khan will be sharing his views on application of biotechnology in biomedical research with particular reference to tuberculosis. I request Dr. Khan to please start the session.
Thank you very much. Indeed, I am rather fortunate to have here with you, and the credit goes to your teacher, professor, whatever you wish to say, Dr. Preeti Sharma. Actually, I was supposed to come to attend the Hindi program on 14th of September in your city. So I thought, let us go to Surat, because I have never been before to Surat. So Preeti told, why not you have 1 or 2 opportunity to have with interaction to the students of our university. I thought that was a good idea. So really, I am honored to be here. You know, beginning of any career, it starts the desk from where you are sitting right now, and journey depends upon how you take it, how you are passionate to further to lead your career. No matter what discipline you are choosing, the important is that it must be consistently taken with passion, with commitment. Definitely there is no reason why one could not get success. So today's talk is, of course, we will be giving very basic. I will try to myself to be very basic, so that it will be so interactive and informative, as well as will be able to communicate each other probably. So बीच में थोड़ा मैं हिंदी भी कोशिश करूँगा to connect you well. Let us try to do that. So as you know, the first talk of my today is application of biotechnology in biomedical research with particular reference to tuberculosis. I put the one disease, a disease is very common among all the societies across the world, and India is one of the leading burden country as of now. When we talk about the application of biotechnology, so first the question arises, what is biotechnology? How we address, how we perceive the term biotechnology? May I have next slide please? So before going to that, let's have, this is our institute, National JALMA Institute, located at Agra. It was developed and taken by the 2 Japanese researchers, very hardcore researchers, and they were the first or second founder directors of the institute also. The building is a little bit curved. If you see the structure of the building, they have designed the building as per the morphology of the bacteria Leprosy. The whole building they have taken into account. The Japanese architect, they have made it very similar as the leprosy bacteria looks under the microscopy. So it's a very robust building, and it has a lot of historical importance from the period of Pandit Jawaharlal Nehru, Radhakrishnan, Zakir Hussain. These dignitaries, they have visited this institute in the past. It was given to ICMR, Indian Council of Medical Research, in 1976. From onward, to look into the researches, particularly leprosy and other mycobacterial diseases. Next, please. So, if you see the biotechnology using the organism or the products of living organisms for human benefit to make a product or solve a problem. So, means if you take bio plus technology, bio plus logy, probably the use of technique in some way to the organism or biomolecule for various purposes depending upon your need and necessity. It could be of varied nature. It could be in the area of the agriculture, your textile, even the medicines. So the vast use of the biotechnology is tremendous. I will be focusing mainly upon the medical related subjects, what the biotechnology has done, what wonders has done, and how it can be taken further also, and how much potential have the biotechnology in the area of healthcare, dealing with the health issues, dealing with the diagnosis, the drug development, immunoprophylaxis and vaccine and so on. Next, please. So, if you go to the history of the biotechnology, the beginning is by any kind of process you make certain molecule or material or germ in bigger quantity. It may be the fermentation technology or the culture or the maintenance of certain bacteria or pathogen, may be the good or bad, depending upon the uses or requirements. So there are basic processes by which they have gone to the various medications on that line, and ultimately if you see these initial studies or the efforts, they lead to the development of newer techniques which return to the gene cloning, genetic engineering, recombinant technology, and the very popular project, the Human Genome Project, we have taken into account. So these are the vast areas. If you go to that side, there are the three developed. I'm not going to do that one. So how the biotechnology has emerged from the basic to that level, it has been given, and now we even don't think that any drug, any molecule, any vaccine is possible without having the role of biotechnology. The application of biotechnology is tremendous in various areas, and now the advanced science or the machines, they made it possible. Whatever you think, you will be able to do that by the application of biotechnology. When we talk about the biomedical research, primarily we mean that our focus is on the healthcare or the health issues. Next, please. So these are the applications. You can see how they can play a different role in different facets. There are food and nutrition is there, bioinformatics is there, drug industry is there. There are a lot of applications of the biotechnology depending upon the requirement. So it has really a big potential. Next, please. So again, if you go to the strictly on the line of the biomedical research, you can define the biomedical research is the broad area of science that looks for ways to prevent and treat diseases that cause illness and death in people and in animals. There are, now there comes the kind of researches. We have the basic research, we have the applied research, and we have the clinical research. If you say broadly, basic research means a research normally we conduct within the laboratory surroundings, within the laboratory, based upon certain assumptions, certain search for certain things to aid or to find out something which is yet to be known, or there is no clear-cut understanding upon the areas. Then it comes to the applied. When we talk about applied, we necessarily mean that there is certain need or the goal of your research For example, somebody has thought, let us see in Surat, what are the major medical hospitals available. So your objective is that, then there could be some approaches. You can start from the one corner leading to the last corner, but that's not possible for you because city is very big, lot of establishments are there. There could be certain procedures or the sampling method or design of your study by which you can achieve your target with limited resources. So this is important. So applied research means something you are going to use. If you are able to know the healthcare, then your goal is how we can improve. Depending upon the outcome of your study, applied study, you will be able to find out what could be the next. You can plan your strategy. So the applied research is directly linked to the certain goal or certain objectives, whereas the basic study depends on certain understanding and findings or the hypothesis of that nature, which is going to be the base of the further development of the science or the advancement of the knowledge. When we talk about the clinical research, that means if we talk about clinician, clinic, we understand that something relates to health of the human. When you use the clinical research, it bifurcates the animal research, in vitro research, laboratory research to the human, or the concern of the research is leading to directly to the healthcare or the certain kind of advanced knowledge with regard to the human or the clinical setup. So these are the basic areas, and ICMR is working on those three areas, but now focus is main upon the applied research and clinical research. Next please. So if you see the recent biotechnology advances in biomedical research, there are a lot of areas. I'm not going to read each and every, but you understand that these are the outcome of the advanced biotechnology which we are doing across the world, and the scientists of the each and every country, they are the laboratory, they are looking for that. So there is a purpose for that. Let me have a brief example of COVID-19 vaccine. See, this was a new virus to the scientific fraternity. We were not knowing much about it. The question was, there was no drug. Even the antiviral drugs are very limited, and those of that categories we are not having any clue how it is going to act upon. The big challenge with the world, including India, was how we can, and you all know how vast we are as far as population is concerned. So it was a big challenge for us, for the government, but all the systems, including the government, the research institutions, ICMR in particular, we sit together and find out the ways to. So ultimately, virus was isolated and cultured in the NIV Pune lab of ICMR, and then the journey of the development of vaccine by Mahbood Biotech was started. Then the serum came into the picture also. So depending upon the requirement, it was the process, I should say the technique or technology which we learned from biotechnology, given a base or the possibility to have such kind of vaccine and manufactured to such huge quantity for the Indian population. So no doubt biotechnology has very, very important role today and in future also. Next please. Let us focus on the disease which I have given you the importance on how tuberculosis is important for us. With regard to tuberculosis, as you know, we have listened and heard about the ancient civilization of Egyptian very long. There is a mention of the tuberculosis there in their history or in their archaeology. So let me say about something more about the tuberculosis. Tuberculosis is a disease primarily affects lungs by a bacteria normally. So bacteria is Mycobacterium tuberculosis, the name was given like that. There is another bacteria, Mycobacterium leprae, for leprosy. So this bacteria is of course very old. A lot of research has been done across the world, in India also, and we are trying hard to at least minimize the infection at the community, so that it is possible that sometime we can say proudly there is no much concern of the tuberculosis in India. And in 2018, our Honorable Prime Minister Shri Modi ji has inaugurated a meeting in the BRICS. There are 7 countries group in the world looking after the tuberculosis: Brazil, China, Russia, South Africa, India, 5 countries. So it was decided that we have to take on the tuberculosis actively, and since we have the drug, so why we are not able to control or minimize the infection in India. And a target of 2025 was given for the tuberculosis elimination or the control very effectively by our Honorable Prime Minister. So lot of activities started from that particular point, and of course the world has set the target for 2030. So very smartly our Prime Minister put 5 years before, so that if there is something to have to done further, there is a time with us. So ultimately it was given the 2025. I should say a lot of work across the country has been done with regard to the tuberculosis. One such study, biggest in the world, having 5 lakh population in India, has been made possible by the Indian Council of Medical Research under the leadership of our division. We were the active part or the partner or the programmers of this survey, and it was done in Gujarat also. We have all the states of the India partner in that study, and that shows that still we have to work very hard, because certain states they have reported infection rate or the incidence or the prevalence is high, despite of the fact that we are trying at our level hard. That means we have still to work very hard on that line, I should say like that. And recently also there was a program in Government of India at the national level in the Mantralaya, about I think it was 9th of September, something like that, 9th, 10th, that it was given. So this particular disease, which we know, next please, which we know that it primarily affects the lung. About 85% of the tuberculosis is confined to the lungs. Lungs is the main organ where the bacteria infect and damage. Remaining about 15% or so, it's very not common, but you must know that tuberculosis can be available any part of your body, and it can cause the tuberculosis. There, the symptoms, the conditions will be different from the lungs. Somebody may not be coughing, somebody may not be having the fever or the symptoms or the weight loss of that nature, which normally lungs tuberculosis produce, but is equally also going to affect your health. So this was dealt at a very higher level, and people have worked on that India still has to take or they have some kind of diagnosis on that part also. Next please. So this is again the site which I have shown that how it occurs there. Next please. Before that, please go back. The TB of the chest or the lungs normally have the 3-4 categories. Sputum, I mean coughing is the one character. Fever remains, maybe not very high. Night sweats, weight loss. These are the important areas. So this is the airborne when we are coughing, the droplet of the, as in the case of your, COVID-19, but it is different. COVID is very highly contagious because of the nature of the virus, but it's a bacteria. So it is, transmission is not very active as in the case of COVID. So therefore, because the droplet, maybe if I have something, it is something here, not beyond that, but still it is one of the cause of the disease concern. So families who have the disease of, tuberculosis within the household, we call scientifically household context, means a person living within the family needs to be extra, cautious and have to preventive measures. Next, please. This is the burden of the tuberculosis. India has the highest burden of TB, and there are one issue more. We have nowadays there is a common, कहते हैं भाई ये दवाई काम नहीं करती है, ये एंटीबायोटिक पहले हम खा रहे थे तो हमारा बुखार खत्म हो जा रहा था, अभी नहीं हो रहा है। तो टीबी में भी एक प्रॉब्लम आ रही है कि इसमें जो डिजीज़ है इसके भी 2-3 स्टेजेस आ गए। एक तो है कि जो हमारी आम दवाइयाँ हैं, 3 दवाइयों का कॉम्बिनेशंस है, वो हम लेते हैं, अगर उससे पैथोजन मर गया तो सेंसिटिव है, ड्रग सेंसिटिव बोलें, अगर नहीं है तो देयर इज सेकंड लाइन ऑफ ड्रग दैट टू बी टेकन, उसको बोलते हैं MDR TB। रिपोर्ट बताती है कि MDR के केसेस बढ़ते हैं अक्रॉस द कंट्री और बाहर के देशों में भी, तो दैट इज़ इम्पोर्टेंट दैट हाउ वी कैन टैकल टू दैट। एंड बियॉन्ड दैट थर्ड कैटेगरी इज़ कॉल्ड XDR, मतलब वहाँ जो सेकंड लाइन जो डिफेंस है, जब हम कहीं कोई लड़ाई करते हैं तो जो हमारी पहली सेना है, सेकंड सेना है, थर्ड है, मतलब जो आखिरी जो हमारे पास में जैसे कहते हैं ब्रह्मास्त्र हमारा है, वो भी कभी कभी बैक्टीरिया के केस में काम नहीं करता है। तो ये कंसर्न है, दैट्स व्हाई इट इज़ अ नेशनल मूवमेंट एंड why the government is putting so much interest on that. So that is there, that's why people, those who are aware and know about the disease somewhere have the awareness among them, the society. So those who are having the disease, they come forward and have the treatment as well. So with regard to this, if you see there are certain regions in the world, they have don't any problem of tuberculosis. Rather they had, but they were able to, suppress, or they were able to overcome the disease. But India, we have, but there are certain countries, their condition is much worse than the Indian also. So though we have the burden, but our efforts is really giving some importance. Next, please. So, if you see, one of the important diseases once upon a time was the HIV, and people have shown that those who have HIV, there is the likelihood of having the disease of tuberculosis high. Because of that, the immunity, body immunity is compromised in the case of HIV and in the case of tuberculosis as well. So because of that, the compromised immunity or the body resistant, you can say normally, these two infections is just they are found together in one person, and that becomes very challenging to treat because you have to treat with the antiviral drug as well as the anti-tuberculosis drug. So this is about the status from 2020, 20 to 20. There is a decline, but still significantly high. Next, please. So, in the area of healthcare, how the biotechnology has taken or contributed the designing of the diagnostic tools or the drugs or the vaccines for tuberculosis. For you people, let us say about the diagnostics. How many of you know about how diagnostic procedures we can say? There is one method. Normally we have to find out the causative agent, how infection, what are the pathogens involved in infection, and there could be many ways for that. Means you have to see the pathogen by your eye. If the bacteria is not visible by your eye, you take the need of the microscopy. So microscopy come into the picture at the early stage, but in the area of tuberculosis, chances of missing the infection, you have to be very known or trained or experienced person to see the microscope and see the pathogen samples and properly diagnose from other bacteria. There could be other bacteria having not the tuberculosis nature, not the Mycobacterium tuberculosis, but they are looking very similar morphologically. So it becomes very difficult to find out. So therefore, somebody there. So now here the role of biotechnology came. Scientists thought that why not there should be some method by which we don't need to rely upon, to depend upon the microscopy. So they have thought what could be. So they thought if be possible to have certain kind of gene which is available in the bacteria, if we can multiply using the certain machines like PCR. So if number of copies of that bacteria is much more or the gene fragment is much more, so we can have certain tools by that we can compare, yes, this particular fragment of the gene is present in the system. So we can say, okay, now the bacteria is there, so person is suffering from the disease. The reason is that in microscopy, if the bacteria are very less in quantity, there is a likelihood that you will miss in your microscopy by the even expert technicians. So therefore, this biotechnology helped to develop a technique based upon the molecular diagnosis. So there are two machines available. Next please, let me go first quickly. So microscopy, then we have gone to the culture. I skip culture because culture is a technique for you understand. If I say apiculture, pisciculture and the sericulture means something you are using at the production level, larger level. In the case of bacteria, there is a culture, maybe the hot solid culture, प्लेट में लोग लगाते हैं, ग्रो करते हैं. अगर आपने किसी लेबोरेटरी में गए तो देखा होगा. कुछ लिक्विड कल्चर भी आते हैं, कोई डाइफिजिया होता है. पर्पस यही होता है कि इस स्पूटम के सैंपल को लेके या जो भी सैंपल लेना चाहे लें, उसमें डालें. सर्टन कल्चर वहाँ रहेगा तो बैक्टीरिया के लिए अच्छा एनवायरमेंट रहेगा, खाना वहाँ रहेगा, फूड रहेगा. So ultimately they will grow, they will multiply in numbers. So that numbers is there. Then on the basis of their culture technique, they can find out कि ये बैक्टीरिया, उनकी जो कॉलोनी बनती है वो अलग अलग बनती है. तो they can differentiate कि ये माइकोबैक्टीरियम ट्यूबरक्लोसिस का कल्चर है. एक तो वो है. अल्टीमेटली जो मैं कहना चाह रहा था, नेक्स्ट प्लीज, ये हाँ गो बैक. सो ये न्यूक्लिक एसिड एम्प्लीफिकेशन टेस्टिंग, ये एक इम्पॉर्टेंट है जो आपसे कंसर्न है. आई विल फोकस ऑन दैट. नेक्स्ट प्लीज. So this is the bacteria, how it looks in the your microscopy or system. It's a very small in the structure. It's very difficult to diagnose and differentiate. Only the lab technician can do that. Next please. So these are the limits of microscopy as I told you. Next we can go quickly. So this is the culture process. The last one is the machine where we use for the another type of culture, advanced culture. Culture will provide you कि कोई भी ड्रग काम करती है कि नहीं करती है, तो उस ड्रग के अगेंस्ट में हम सेंसिटिविटी देख सकते हैं. दिस इज वन अपार्ट फ्रॉम द डायग्नोसिस. नेक्स्ट प्लीज. दिस इज द कॉलोनी. इफ यू पुट इन द कल्चर you will find out the culture colony, maybe the liquid or the solid used. There are certain machines are used. There are weekly examinations and 3 to 6 weeks needed for that. After 8 weeks you can see and prepare this kind of advantage you will get from that. Next please. So this is about the PCR tool which I mentioned about for you people. This one for the biotechnology that is being used that. So it is very rapid. Within 2 hours you can get your result as compared to the microscopy, and moreover you can also have very accuracy. Sensitivity is above 90%. So there is a less chance of having missed diagnosis as in the case of microscopy. So this is only because of the possibility of the use of biotechnology. That's why, because see, it's difficult to go into detail because at your level, but the understanding is only here. What I want to convey to you all, that biotechnology has tremendous scope in various areas, and in particular what I am dealing today with biomedical research is really tremendous. And this biotechnology has given a chance to the scientists to look into the further various aspects of the disease. So, but there are limitations also, because the machine requires the money, the setup, the laboratory facility also. So that is also there with that. Next please. Next. Yeah, there are certain publications also what normally scientists do with that, how much this technology can be used, and accordingly they have based upon the certain molecular based diagnosis for the tuberculosis they have done. And of course the main contribution was the biotechnological methods available. That's why they were able to make survey any diagnostic materials or the drugs. Even for drug designing also you need the bioinformatics, but ultimately to develop that drug or the vaccine in the huge quantity, the tool of biotechnology. Next please. These are the methods. There are lot of varieties of applications of the biotechnology in the medical care, medical health care. Because see, just amplification, as I told you, that is possible only within 2 hours or 1.5 hours, and your result can be available. Whereas culture requires sometimes 3 weeks, more weeks, 4 weeks, 5 weeks, and microscopy have only 40% sensitivity. So means 40% is very less. You cannot rely. Somebody has given microscopy, you are negative, but that there is a chances of a likelihood that B may be positive, but microscopy is giving negative by 40% because sensitivity is so low. So biotechnology or the PCR system which has given to us it over 90% sensitivity, so that we can say yes, if negative, negative, positive, positive. So that kind of tools we have got on the basis of the uses of biotechnology. Next please. Again there is a system, as I told you about the GeneXpert is a machine which we use in the, is a kind of PCR machine, can be have within the one. We have developed one indigenous van, big bus. That bus has the facility of the X-ray machine, microscopy, diagnosis, and the GeneXpert machine also full. That machine was used across the country. We have 26 buses such nature. I don't know if I have photograph. If I have, I will show you. So that was possible because of the tools, the advanced tool which we have used in the area of tuberculosis. Next please. Again there was another machine which India has developed. It was called TrueNet. It was little bit cheaper than the GeneXpert, and most of the sensitivity was at par with, and TrueNet was having advantage to reach the machine to the village level also, because it was not requiring a very good developed laboratory conditions. It was having the advantage, whereas the GeneXpert is good, but it cannot be taken to the village level because it has certain facility where temperature has to be maintained, maybe by the air conditioning. Next please. Again the paper published from the scientific report from the Indian authors regarding the use of these machines or the tools or the molecular diagnosis of tuberculosis. Next please. Now we come, as I told you, that there are certain tuberculosis, they are not with the lungs. There are certain, they are maybe the bone, maybe the skeleton, maybe the eye, maybe the brain, maybe the other part of the body. So how can we detect? Because we need the sputum. हमें sputum चाहिए तो वहाँ तो मिलेगा नहीं, तो फिर कैसे करेंगे? We will stuck, and they are about 20%. So we cannot ignore them. तो उसके लिए एक टेस्ट डेवलप किया गया, ट्यूबरकुलस TST, ट्यूबरकुलिन स्किन टेस्ट दिस इज कॉल्ड। सो नॉर्मली क्या करते थे, उन्हें छोटा सा इंजेक्शन लिया, पतला सा बिल्कुल, जहाँ आजकल जो आता नहीं अपना ये इसका इंसुलिन का इंजेक्शन होता है, हाँ ऐसे आता था वो, तो यहाँ पे लगाते थे, उसका एक इम्प्रेशन आता था, उसको कंपेयर करते थे। बट दैट वाज आल्सो वेरी नॉट सेंसिटिव, सम टाइम जो करते थे वो कहीं कुछ मिस्टेक भी हो गया। तो एक मॉलिक्यूल ढूंढा गया हमारे ब्लड में, उस मॉलिक्यूल का लेवल बढ़ जाता है अगर टीबी का इन्फेक्शन होगा। तो इंटरफेरॉन गामा, दिस इज कॉल्ड IGRA टेस्ट, इंटरफेरॉन गामा टेस्ट, उसको ब्लड में मॉनिटरिंग किया और करने के बाद में लोगों ने पाया कि दिस इज़ वेरी गुड टू फाइंड आउट द ट्यूबरकुलोसिस दोज which are not associated with lungs, this called latent tuberculosis, जो अभी अंदर है हमें पता नहीं है बट इट इज देयर। तो इसका भी हम लोगों ने प्रयोग किया। इट वाज आल्सो पॉसिबल बिकॉज द बायोटेक्नोलॉजी, बिकॉज इट इज टू बी प्रोड्यूस्ड एंड मैन्युफैक्चर्ड इन बल्क बाय द फार्मास्यूटिकल इंडस्ट्री, बट इट इज अगेन द कॉस्टली, महंगा है, सरकार के लेवल पे इतने बड़े कंट्री के लिए लेना बड़ा मुश्किल है, बट दे हैव टेकन एट दी हॉस्पिटल केयर सिस्टम ऑल्सो, महंगा पड़ता है ये। सो ICMR ने एक नया तरीका निकाला, जो पहले स्किन टेस्ट था उसमें मॉडिफाई किया। अभी प्रधानमंत्री जी ने कुछ दिन पहले ही इसका जिक्र किया था हमारे यहाँ, जब 15 नवंबर, 7 नवंबर 8 नवंबर को, सॉरी सितंबर को जब मीटिंग हुआ था, हम कहते हैं उसको साइट टेस्ट बोलते हैं, वो भी स्किन टेस्ट जैसा ही है बट डिफरेंट है, उसकी सेंसिटिविटी पुराने वाले टेस्ट से बेहतर है। वो गवर्नमेंट प्लान कर रही है अपने सारे पेरिफेरल सिस्टम में, गांव के लेवल पे, ब्लॉक के लेवल पे, ग्राम पंचायत के लेवल पे उसको लेने के लिए, दैट इज़ चीपर। तो वो भी एक ICMR का अचीवमेंट है। दिस इज आल्सो पॉसिबल एंड इट वाज बिकॉज ऑफ द रोल ऑफ बायोटेक्नोलॉजी। सो व्हेन वी रिक्वायर समथिंग इन बल्क, in quantity to cater something, you cannot avoid, you cannot escape the one discipline, that is the field of biotechnology, because the mass level production is really depend upon that, and of course we have very good laboratories now in India, and drug companies are very stronger, I should say, in India. They have developed the vaccine or any kind of drug of that level to that point. So if you see the basic, whatever the concept, maybe at the school you might be learning, but these are the application side of biotechnology, how we can have, how we successfully have utilized them. This is important. Next please. So this may be the different approaches from beginning to onwards, how we have reached the uses of biotechnology from the beginning, then using the tools, going to the advanced systems, and it is going to be utilized by the what I believe as a scientist, that drugs or the diagnostics or even the vaccines, here the major contribution depends upon the modern tools, and these are the one of the area or the discipline they have tremendously supported to the scientists to reach this level. Equally in the area of the agriculture scientists, जहाँ पे बड़े लेवल पे नए वैराइटीज़ हैं, स्पीशीज़ हैं जो पैडी के बनाते हैं। अभी एक मॉस्किटो कंट्रोल में एक यूज़ हुआ है बैक्टीरिया बेसिलस थोरेंजियंसिस, हमारा एक ICMR का इंस्टीट्यूट है पुडुचेरी में, उन्होंने डेवलप किया है, और वो उन्होंने एक स्टेराइल मॉस्किटोज बनाया है, एक कॉलोनी तैयार की थी, उसको लिया है वहाँ पे। दे वांट टू एलिमिनेट ए पर्टिकुलर स्पीसीज ऑफ मॉस्किटो रिस्पॉन्सिबल फॉर ट्रांसमिशन ऑफ मलेरिया बाय द यूज ऑफ सर्टेन molecules are changed in the system at the genetic level, where they have produced that variety of sterile progeny. They can no longer propagate in the population, and ultimately the density will be low, so there is less chances of having the transmission of malaria. So I think those who are coming from the discipline of biotechnology, they must feel proud of it. It's very good. Of course, the job, other things are challenging, but that is everywhere. But the applications of biotechnology is tremendous. And I told you earlier also, it requires consistent efforts, and those who are to take the biotechnology as a career is really important, that you must strive on. Next, please. So these are some vaccines or drugs by the help of the biotechnology. It has been developed or in the pipeline. There are 2 molecules for the development of vaccine for the tuberculosis. It is at the advanced stage, and possibly in near future there could be very effective vaccine available for tuberculosis also. There is one vaccine we have tested, that is MIP, Mycobacterium indicus pernae. ये लेप्रोसी से मिलता जुलता बैक्टीरिया है जो फ्री लिविंग है, नॉन पैथोजेनस है. इसके जीन को मैनिपुलेट करके एक वैक्सीन बनाई गई है जो ट्यूबरक्लोसिस के लिए टेस्ट की जा रही है. हमारा ही टीम है जो इसको इंडिया में कर रहा है. 12,000 आदमियों पे इसका टेस्ट, 12,700 कुछ लोगों पे टेस्ट हमने इसको 2019 में शुरू किया था. आज इसको करीब मेरे ख्याल में 1 साल और बाकी है इसके फाइनल आउटकम को. वी डोंट नो वेदर रिसर्च एक्सपेरिमेंट, देयर इज वन वे, आइदर सक्सेस और फेलोर, वी डोंट नो. बट फेयर मस्ट नॉट बी देयर कि अगर ये कामयाब नहीं है तो हम आगे नहीं करेंगे, बढ़ेंगे कैसे. सो वी हैव लॉट ऑफ एक्सपेक्टेशन ऑफ दैट वैक्सीन, बट स्टिल इट इज़ टू अर्ली टू से समथिंग. दैट इज़ बिकॉज final data analysis is still to be done after 1 year of time, maybe 2023 it is expected to be. So these are the applications of biotechnology. Next please. Again, then there is a area of nanoparticle also. Now it is also coming in a big way, because if nanoparticles, if I say very precisely, this is the tool by which you can target your molecule or an agent to a particular location or site. So thereby you can minimize the concentration of the drug or the agent which you want to inoculate to make effective results. So this technology has given us a chance to precise and redosing. Dose schedule can be given less quantity also because of that. So this is also one of the area, and it has a lot of applications in the tuberculosis as well as other area. Next please. So again the same thing. Next please. Publication part. There is also one application that it has been used, how the various stages of the pathogen can be taken on and can be dealt effectively. So that is also there. Next please. Again next, these are the examples. आप इसको कर दीजिए, because these are the publications. जिस कोविड वैक्सीन की बात है उसमें आप लोगों को ये BCG की बात है, जो मैं MIP की बात कर रहा था अभी, that was the thing. Next. So ये वैक्सीन के जो एक्सपेक्टेशंस है across the world, उसमें किसकी क्या संभावनाएं हैं. अगेन ये उसके जो हमारे पास इम्पोर्टेंट टूल जो हम लोगों ने काम किया है, हाउ अगर हम अटेंड नहीं करते तो कहाँ जाते, हमारा इन्फेक्शन रेट क्या होता. आफ्टर द एक्टिव अटेंड व्हाट वी एज्यूम दैट इफ 2025 तक हमें कुछ करके दिखाना है, दिस इज पॉसिबल, बट इट इज़ रियली बिग चैलेंज फॉर अस. नेक्स्ट प्लीज. सो दिस अगेन द management of tuberculosis. There are a lot of issues. Once my professor has said that the pathogen, they are more smarter than us. So whatever plan we do, they also take it on as a challenge, and they manipulate genetic level they becomes accustomed to fight with the drugs or the vaccines available. So because you see the Darwinism, the theory species selection of species is rather survival of the species. If you say survival of the fittest, those who are fit to their environment, they will survive. So they also try to maintain their species, because this is also given by the nature. So they have all the potential too. So the fight between the researchers and the pathogen is going on. I don't know how long we have to. Both groups has to equip well. Next, please. Thank you very much. Yes, anybody? Any questions you just think it could be of what you are thinking? Let me try if I can. Yeah, please.
Sir, how can we prepare purpose for the PhD admission for the PhD?
Means
how can I select topics?
PhD with regard to biotechnology or with regard to any biomedical research?
With regard to any life science.
Life sciences. See, in my days it was very difficult, because we used to spend hours and hours in the library. Dr. Preeti Sharma is here. We had the very good library in Central Drug Institute, with all the available periodicals, current science, professors, scientists. They used to rush on weekend, Sunday and Saturday to see the new. But now we probably very, very fortunate, I should say. A lot of things are available at your fingertips by the Google, but so many literature search engines are available. I think the first of the issue, I will be talking this in my second lecture, but since you have talked, so let me reply. You assume anything, feel that what is the relevant information available, why we want to do this kind of research, is there any need at your level, at your national level, at your global level? So need will put you certain questions. On the basis of questions, you will try to find out. Then you can formulate your hypothesis. Then you can see your objectives. Then you can see your title, what could be, and what could be done within the feasibility, within the resources what you have. That's very important. You can think of anything very high. If resources are not available, feasible नहीं है, तो फिर वो आपके लेवल में नहीं हो पाएगा. So जब थोड़ा बड़े हो जाओ तो उन चीज़ों को सोचो. जब लेबोरेटरी में, अच्छे लेबोरेटरी में जाओ जहाँ सब कुछ अवेलेबल है. बट एट द यूनिवर्सिटी लेवल जो आपके लिमिटेड रिसोर्सेज हैं उनको देखो, उनमें जो बेस्ट आपको लगता है. बिकॉज साइंस मस्ट लीड समथिंग. आपकी डॉक्टर थीसिस से कुछ ना कुछ निकलना चाहिए. खाली वो किताब में अलमारी में बंद होकर के लाइब्रेरी के किसी कोने में रैक में लगनी नहीं चाहिए. एक दो पेपर भी आपके ऐसे छपें जिनको दूसरे लोग पढ़ करके कुछ ना कुछ उससे एडवांस की तरफ जाएं. ऐसा तो कम से कम पीएचडी में कोई ना कोई पॉइंट आउट होना चाहिए, इन माय व्यू. या प्लीज.
through which India is really curing tuberculosis. Is there any database where I can find all the gene coding and sequences of this?
Yes, actually see, the Department of this Central TB Division, we call CTD, under the Ministry of Health and Family Welfare, Government of India. Government of India has very good policy. They have the Nikshay portal across the country. So whatever they diagnose at the village level, at the block level, at जिला level, वो वहाँ के सारे अधिकारियों को ये आदेश है कि उनको उन पेशेंट का नाम जो भी है डिटेल में है दे वहाँ पे. तो पूरा डाटा उनके पास अवेलेबल है कि पूरे कंट्री में हमारे यहाँ कितने पॉजिटिव हैं, कितने लोग ड्रग पे हैं, कितने लोगों का ड्रग ख़त्म हो गया है, कितने लोग ऐसे भी हैं जो ड्रग से रिस्पॉन्ड नहीं कर रहे, जो मैंने बताया था आपकी MDR के केस में, राइट। सो ये पूरा अवेलेबल है। एंड चूँकि गवर्नमेंट रिसर्च खुद नहीं कर सकती है, जो ICMR बॉडी है, DBT है, DST है, CSR, जो भी हमारी डिफरेंट बॉडीज़ हैं, जो जिनका प्राइमरी उद्देश्य यही है। मेडिकल कॉलेज भी हमारे उनका प्राइमरी उद्देश्य नहीं है, हमारी यूनिवर्सिटीज़ भी प्राइमरी उद्देश्य नहीं है रिसर्च, लेकिन विदेशों में ऐसा नहीं है। उनके पास एक यूनिवर्सिटी मीन्स एवरीथिंग, दे हैव विद इन द कैंपस एवरी फैसिलिटी, मेडिकल है, इंजीनियरिंग है, ये है, इट डिपेंड्स अपॉन द फैसिलिटी। इंडिया में थोड़ा समय लगेगा, बट देयर आर सर्टन लेबोरेटरीज या सर्टन यूनिवर्सिटीज़ जिन्होंने इनके पास है। तो डाटा इज़ अवेलेबल, किन किन इश्यूज़ पे हमें काम करना चाहिए ये भी अवेलेबल है। अगर आप जाएं हमारी वेबसाइट पे, सेंट्रल टीबी डिवीज़न गवर्नमेंट ऑफ इंडिया, आप गूगल में डालें निकलेगा, CTD के वेबसाइट पे जाएं, वहाँ पे बहुत सारे स्कीम्स हैं, नए हैं प्रोग्राम्स हैं, गाइडलाइंस हैं, वहाँ पे किन किन एरियाज़ में रिसर्च करने की ज़रूरत है वो सारी चीज़ें दी हुई हैं। व्हाट आर द ग्रे एरियाज़ वेयर वी स्टिल डोंट हैव मच क्लियर अंडरस्टैंडिंग। सो उनको देखेंगे तो देन यू विल बी एबल। ऑफ कोर्स जो इंस्टीट्यूट्स काम कर रहे हैं, जैसे इंडियन काउंसिल ऑफ मेडिकल रिसर्च के 4 इंस्टीट्यूट्स हैं जो प्राइमरली काम कर रहे हैं ट्यूबरकुलोसिस पे। एक ICMR JALMA, देन NIRT नेशनल इंस्टीट्यूट ऑफ ट्यूबरकुलोसिस चेन्नई, NIRT जबलपुर ICMR का है, देन एक RMRC भुवनेश्वर। तो ये 4 हैं जो बाकी सब करते हैं कुछ कुछ लेवल पे, बट दे आर फोकस ऑन देयर। जैसे NIN हैदराबाद है, अब उनका पूरा फोकस न्यूट्रिशन पे है। जैसे हमारा वेक्टर बाउंड डिजीज़ पे है, कुछ बिल्कुल जैसे NIV पुणे है, वायरस डिजीज़ लेबोरेटरी है वो। तो जितनी भी वायरल डिजीज़ वहाँ वो लोग करते हैं। TB पे ये 4 इंस्टीट्यूट्स काम करते हैं। एंड आई टेल यू, TB से डेथ बहुत होती है, लेकिन क्या है कि वो हम उसको उस लेवल पे, एक्यूट लेवल पे नहीं होती है, एट मास नहीं होती है, तो क्या होता है हम फोकस नहीं कर पाते हैं। अब वही होता ना कि अर्जेंसी किधर है। जैसे कोविड जब आया तो इतनी अर्जेंसी थी, हम कुछ सोच नहीं सकते थे। हमारे बहुत सारे स्कीम थे जो चैलेंज हो गया, कैसे करें, कैसे कंटिन्यू करें। फॉर एग्ज़ाम्पल TB को आपने किसी को डायग्नोस कर दिया तो दवा तो देनी है ना। अब उसको दवा देने के लिए भी उस ज़माने में उस तक कॉन्टैक्ट नहीं है, टेलीफोन लाइन नहीं मिल पा रही है, आदमी आ नहीं सकता, हम उस तक पहुंच नहीं सकते, लॉकडाउन है, ये है, ऑल आर वेरी इम्पोर्टेंट। तो उसमें जो चैलेंजेस आए उससे जो है लोगों ने सीखा कि नहीं, अभी कुछ हमें और करना चाहिए। एंड भारत सरकार ने बहुत कुछ किया भी है। दैट्स वाई जो लेबोरेटरीज जो इक्विप्ड नहीं थी उनको उस तरह से बनाया भी है। बट मैं तो कहता हूँ TB के लिए आप सबको हाथ जोड़ के आना चाहिए, एक अपने लेवल से एक बहुत ही पॉजिटिव प्रयास करना चाहिए, तभी पॉसिबल है। अगर हमारी कंपनी नहीं जुड़ती है, सरकार एज सच या इंस्टीट्यूशन के लिए करना ये नाकाफ़ी है। जब तक कम्युनिटी मूवमेंट नहीं इसमें शामिल होगा, मुश्किल है। डाटा इज़ अवेलेबल, हम लोगों की जो वेबसाइट है वहाँ भी अवेलेबल हैं। अगर कोई रिसर्च करना चाहें तो देर आर एरियाज, देर इज़ नो क्वेश्चन अबाउट इट। थैंक यू। या प्लीज सर। Right.
Demographic distribution you have shown to us throughout the world. I was not aware. Thank you for updating that. India is at risk.
Yes. Yeah.
What I have witnessed that color chart which you show, is it related to the population density because Asian countries are facing more threat towards tuberculosis? But if I say yes in that case, then African countries also having high prevalence.
There are.
So is there any, what are the indicators?
Indicators, okay. Actually, see, tuberculosis is first of all the disease of the poor society, and supplement with the, coupled with the malnutrition, because malnutrition also affect in some way to develop or make the presence of tuberculosis bacteria. So in African countries and in India also, in those populations where the sources are very limited, food qualities are not a balanced diet, that also somewhat make them weak the immune system, the body, where bacteria can be actively becomes active. And in those cases, it has been seen that sometimes the bacteria is present in the body, but it's not able to flourish. So it remains in the form of latent, and nothing to much concern of that. Because of the social system and the drug, there is also one reason in India why it is high. Because of the awareness or the community participation, the schemes are there, but those who are having the infection, they are not being attended on time manner. So they are used to transmit the infection to the society or the community, and as a result it remains. But once, this was the purpose for us, you have to at one go find out what could be the threshold, and then you plan to target those populations they are having the highest, as your case is that. So there is certain states they are showing, but not even the Delhi, the Chandigarh, they have the highest record of prevalence of tuberculosis. टीबी के लिए बता दें, इसका जो पैरामीटर है, यूनिट है, 1 लाख में कितने केसेस हैं, हर चीज़ की एक यूनिट होती है. हम टीबी को जब नापते हैं तो मापते हैं पर लाख पॉपुलेशन. इंडिया की पॉपुलेशन बहुत है, तो पर लाख में अगर देखें तो वैसे हम बहुत निकल जाते हैं, वो भी एक बात है. और दूसरा क्या है कि कुछ राज्य ऐसे हैं जहाँ पे वर्कर्स हैं, माइग्रेटरी वर्कर्स हैं, जो बहुत ही लिमिटेड जगहों पर रहते हैं, फैमिली बिल्कुल क्लोज कॉन्टैक्ट में रहती है. तो उनमें से अगर किसी को है, किसी बंदे को, तो उनके फैमिली में होने के चांसेस बहुत ज़्यादा हैं. वो भी एक रीज़न है. और उनकी अप्रोच जो है वो मेडिकल या हेल्थ केयर तक नहीं हो पाती है. दैट इज़ देयर. थैंक यू.
सर, एक रीज़न ये भी है कि जैसे मेडिकेशन चालू करते हैं और फिर थोड़े दिन में उनका बुखार उतर जाता है, तो मेडिकेशन स्टॉप कर देते हैं.
एग्जैक्टली, यस. दिस इज़ कॉल्ड नॉन कंप्लायंस. हाँ, ये भी बहुत इम्पोर्टेंट है हमारे इंडिया के लिए. कि क्या होता है कि जैसे आप कहते हैं ना भी हमारा बीमारी अभी ख़त्म करो, दवाई के बजाय हमें इंजेक्शन दे दो और हमारा बुखार अभी उतर जाएगा, हम काम पे चले जाएंगे. तो कहीं ना कहीं टीबी में क्या होता है, जब हम दवा लेते हैं शुरू में तो बड़ा अच्छा काम करती है, मतलब तो ठीक हो गया, तो जो डिसकंटिन्यू है. दैट्स वाई मैं एक एस्पेक्ट को मैंने बात नहीं किया है. नाउ ट्रीटमेंट ऑफ टीबी वाज फॉर 1 year. इट वाज ब्रिंग डाउन टू 9 months, bring down to 6 months, bring down to 4 months. Now we are thinking to make it 3 months. So 3 महीने पे बात आके भी रुकी है कि 3 month तक अगर हमको बिकॉज जितना लंबा ट्रीटमेंट ड्यूरेशन होगा ना, कंप्लायंस उतना ही मुश्किल होगा. बोले कितने दिन खाएंगे यार, छोड़ो नहीं खाते. तो कहीं ना कहीं ये टेंडेंसी आती है आदमी में. अगर भाई 3 महीने आप रेगुलरली खा लीजिए, आप ठीक हो जाओगे, तो कहीं ना कहीं उनका जो रिस्पांस है वो पॉजिटिव होगा. तो ये भी एक अच्छी बात है. बल्कि ICMR इस पर बहुत ही और कुछ नई दवाइयाँ भी हैं जो हमारे टाइम स्लॉट को कम करती हैं. 2-3 दवाइयाँ नाम को नहीं लिया, जैसे बेटाक्लोइन है, अभी एक नई दवा बनाई भी इंडिया में अवेलेबल नहीं है, अभी शुरू करने जा रहे हैं. वो दवाई ऐसी है जो काफ़ी इफ़ेक्टिव है, लेकिन सबको नहीं दी जा सकती, गवर्नमेंट के ही से मिलेगी, क्योंकि जिन जगहों पे ड्रग रेजिस्टेंट ट्यूबरकुलोसिस है उसमें उसका योगदान ज़्यादा अच्छा है. अभी प्रोफाइलिसिस देने की बात हो रही है ताकि कम्युनिटी में उन लोगों को दिया जाए जिनको होने की संभावनाएं ज़्यादा हैं, जैसे जो हाउस होल्ड कॉन्टेक्ट्स हैं. तो इंडिया इज़ रियली थ्राइविंग ऑन दैट. वी मस्ट सपोर्ट द गवर्नमेंट एट आवर लेवल. यही मेरा रिक्वेस्ट है. हाँ, एग्जैक्टली, बिल्कुल. अंडर वन अम्ब्रेला we must fight tuberculosis under one umbrella. There are different components. Society is equally important. Research are important. जो प्रोग्राम इम्प्लीमेंट करते हैं उनकी बड़ी जिम्मेदारी है कि कितना इफेक्टिवली करते हैं. जो डाटा मेंटेन करते हैं उनकी भी जिम्मेदारी है, ताकि वो एक निगाह रख सकें किस हमें एरिया में फोकस करना है. तो रियली आई थिंक इट मल्टी फेसेट अप्रोच जब तक करेंगे, आई होप कि डेफिनेटली 25 हमारा टारगेट है, लेकिन लेट अस सी जो वर्ल्ड टारगेट है 2030, वहाँ तक पहुँच के अगर हम सिग्निफिकेंटली कर पाएँ, मैं समझता हूँ हमारे कंट्री के लिए बहुत बड़ा योगदान होगा. या
Genetics of population particularly which is more susceptible to tuberculosis?
Okay, I'm happy to. So, it's a good question. It has been shown that there are certain population, they are having, they are more prone to getting the infection as compared to others. But this is not very significant. Probably the strain of the Mycobacterium tuberculosis circulating in a population decide much more. Suppose, for example, let me have an example of the Beijing strain of the tuberculosis available in Sikkim, northeastern part of India, that is XDR tuberculosis, highest level of resistance. The drug is available with us, is not working on that. That population is very close to China. We have seen the phylogenetic of that particular pathogen, and we have linked that once upon a time, long back, it was the population somewhere that strain has got into the Sikkim. That is very dangerous. So I should say yes, but by and large, population has not. I mean, you can't say if somebody is not remain uninfected with the bacteria because they have the immune system of that level. No, it's not possible. Vaccine, the BCG, when we have got in our childhood, it was believed that it is going to have the long-lasting protection after but that is also not true. It is effective at the childhood level, but the adult is a question. Therefore, ICMR is going to conduct a study on the role of BCG in the adult population. अभी वो चेन्नई का एक हम लोग स्टडी करने जा रहे हैं, क्योंकि वो पूरी दुनिया में वही एक वैक्सीन है और वो इंडियंस ने अपने यहाँ बहुत रेगुलरली लगवाया है. बाहर जो है लोग नहीं लगाए हैं, लेकिन इंडियन पॉपुलेशन में बच्चों में ये अच्छी बात है कि गवर्नमेंट ऑफ इंडिया ने बहुत पहले जब भी शुरू हुआ था तो बीसीजी सबको स्कूलों में पकड़ मुझे तो याद है हम तो स्कूल से भाग जाते डर के मारे कि अभी वो टीका लगाने वाले आ गया, यहाँ कर देगा, कुछ भाग जाते थे. बट पेरेंट ने भी पकड़ा के लगवाया, तो वो एक स्ट्रेंथ हम लोगों का था. बट नाउ अब क्या है कि ओवर ए पीरियड ऑफ टाइम बीसीजी का जो रोल है वो बच्चों में तो है इफेक्टिव, ज़रूर देना चाहिए, मगर एडल्ट होने के बाद कितना वो है वो थोड़ा सा इट नीड्स टू बी अगेन to do research on that. So I do hope कि maybe that study can reveal some important information.
Thank you very much, sir. Now we have a 15-minute break. Afterwards, we again gather the second session.
I will tell you in the second part. This will be more, concerned with your PhD topic. This is how you will get the funding agencies, how you can write a good proposal. So that part is also very important for you. Thank you very much.
Thank you.